In this video, we're going to talk about the stages of infection. So to start with, an individual that's immunocompromised. This means that they're more susceptible to infectious disease. And there are many things that could make a person immunocompromised. Extremely old age or extreme youth, like newborn, infant, would be immunocompromised. Any type of a genetic disorder that will affect the immune system, anybody who's recently undergone surgery or an organ transplant will have a weakened immune system. Pretty much anyone with any other type of primary disease like cancer, diabetes, liver problems, someone under chemotherapy or under immunosuppressive drugs, extreme stress, and just having any other type of infection, whether it just be a cold, flu, or even something more serious, could compromise the immune system. A true pathogen. This is a pathogen that can infect anybody, whether they're healthy or whether they're immunocompromised. So, for example, influenza virus could infect anybody. Malaria could infect anybody. So, true pathogen infects someone healthy or immunocompromised. Opportunistic pathogen, just like the name sounds, it'll infect somebody when it has the opportunity. So this is a pathogen that will only infect someone who's immunocompromised or somebody who already has a primary illness. Some examples of opportunistic pathogens, you're going to hear a lot about Pseudomonas. Pseudomonas is a healthcare associated infection, and it's found in the hospital environment. In fact, a recent study showed that a lot of soap dispensers in the hospital contain Pseudomonas. So this is an opportunistic pathogen. It can cause respiratory illnesses for the most part. Another one, Candida albicans. This is a yeast infection. And yeast infections typically infect somebody who's on a broad spectrum antibiotic that may kill off the normal flora and allow the yeast to take over. Again, another opportunistic pathogen. This is a really important term that you're going to see a lot for the rest of the semester. A virulence factor. And I'll abbreviate it VF. A virulence factor is any trait that makes a pathogen or makes a microbe more pathogenic. And there are so many things that could make a pathogen more dangerous. So any of the things we've talked about already, like forming a biofilm, forming a biofilm that allows the pathogens to be sticky and to stick to the linings in the human body. Capsules, which allow the microbe to hide out from phagocytes in the human body. Pili, which allow the microbes to exchange genes for antibiotic resistance. Any type of antibiotic resistance could make a pathogen more dangerous. So anything that will make the pathogen more dangerous to you is a virulence factor. Okay, so the first step in the infectious process is entry. Okay, so first the pathogen needs to enter into the human body. And there's two ways a pathogen could enter. Exogenous pathogens, meaning the pathogen's coming from outside the body. So this is what you would normally think about, like maybe inhalation. You inhale respiratory droplets in the air, and they may contain like a flu virus. Other forms of exogenous agents is maybe like an insect or animal bite that allows the pathogen to penetrate the skin. Most pathogens need to get in through a mucous membrane. So eyes, when you rub your eyes in your hands, contain the pathogen, or through sexual transmission. Okay, sexually transmitted diseases. Another way the pathogen could enter is from mother to fetus. Okay, so or either during birth or during the pregnancy. So exogenous is coming from the outside. Oh, and don't forget, also you could ingest the pathogen in food. The second way a pathogen could cause disease, it could be an endogenous pathogen, meaning the pathogen comes from within. How this happens is when normal flora, either they get into the wrong part of the body. So, for example, E. coli. E. coli is part of your normal flora, and it lives in your intestinal tract. So that would be totally normal to have E. coli in your large intestines. But if the E. coli got into the urinary tract, then it could cause a UTI. So E. coli could cause a UTI if it gets in the wrong place. So this would be an example of an endogenous infection. Another way endogenous infection can occur is if the normal flora goes out of balance somehow. So for example, everyone has a little bit of yeast as part of their normal flora. And usually the bacteria outnumber the yeast and keep them under control. But if someone's on a broad spectrum antibiotic, it could potentially wipe out all those normal flora, bacteria, and allow the yeast to overgrow, and then it'll become a yeast infection. So these are how endogenous infections occur. So like I said, the portals of entry include skin. Bacteria don't have the ability to just go through your skin because your skin is very thick, it's very dry, there's antimicrobial substances. But anytime there's an open wound or like a bug or animal bite, this is how bacteria can enter through the skin. Gastrointestinal tract, which is a very common portal of entry when bacteria enter through food or drink. Respiratory tract, another common portal of entry. Urogenital tract, which mostly includes sexually transmitted diseases. And transplacental, this is anytime the illness is passing from the mother to the fetus. And there are only select diseases that have the ability to cross that placental barrier. And those diseases we abbreviate as STORCH, which stands for syphilis, toxoplasmosis. The O is other diseases because they ran out of letters. So the other diseases are Hep B, AIDS, and chlamydia, rubella, cytomegalovirus, and the herpes simplex virus. So these are pretty much the only infectious diseases that can cross that placental barrier. The infectious dose. This is important. This is the minimum number of pathogens required to cause illness. And typically, the lower the number, the lower the infectious dose, may mean the more easily the infection can spread. So some examples just to show you. Measles virus. It only takes one virus, inhalation of one virus, to cause a measles infection. So that's why measles is so easily spread, and why people who are not vaccinated against measles are at great risk for this infection. Another one, Shigella. Shigella causes a intestinal food poisoning, similar to like vomiting, diarrhea, similar to Salmonella. But Shigella, you only need to ingest between 1 and 10 cells, which is barely anything, to get the illness. Now, if you look down at the bottom here, Salmonella, on the other hand, it's ingestion of 10,000 cells to feel the illness. So this is a great difference in infectious dose. So let's review. A true pathogen. A true pathogen is a pathogen that can infect anyone, whether they are healthy or immunocompromised. Whereas an opportunistic pathogen will only infect an individual who's already immunocompromised. What is a virulence factor? Remember, a virulence factor is any trait that makes the pathogen more dangerous. Such as a biofilm, a capsule, pili, antibiotic resistance genes, anything like that. An exogenous pathogen is one that comes from the outside. So it has to enter from the outside of the body. Well, an endogenous comes from an imbalance or a normal flora getting into the wrong part of the body. So it's a normal flora that somehow caused infection. What are the main portals of entry? Remember, this includes mostly respiratory, so inhalation, ingestion in food, skin, if there's an open wound in the skin, urogenital pathway, so like a sexually transmitted disease, or transplacental. Can bacteria penetrate intact skin on its own? The answer is no. The skin needs to be open in some way. What is storch? Storch is those diseases that can pass transplacental. What is ID? This is the infectious dose, the minimum number of pathogens it takes to cause the illness, whether they need to be ingested, inhaled, or any other form of entry. In terms of ID, what would make a pathogen more virulent? This would be a lower infectious dose would make the pathogen more virulent.